Okay, so let's speak a little bit about non-regular languages and at least see one example of such a language. And I think I already mentioned this language as an example earlier. So consider the language which is all string, which is a sequence of zeros followed by a sequence of ones, such that the number of zeros and one is the same. Now, intuitively, this is not regular because to recognize it, you need a counter, and regular languages are essentially, languages that you cannot recognize them by using unbounded memory. You can recognize them only using a finite number of bits. This, of course, sounds very hand-wavy, and we will formalize all this intuition in follow-up lectures. But let me just state for the time being that this language is not regular. 0 to the n, 1 to the n is a non-regular language. And as I said, we don't really have the tools to prove this theorem at that point. We will prove it later on. Let me mention now that we can use closure properties sometimes to prove that something is not regular, right? So if two languages are regular, their intersection is regular, right? So if I have, for example, a language that I do not know if it's regular or not, but I can intersect it with some regular language and get a language which I know it's not regular, like the language above, then I immediately know that there is no hope and the language is not regular. Similarly, we know that the language, regular languages are closed under complement, which means that, if a language is regular, its complement must be regular and vice versa, right? So, for example, all the strings which are all the strings that are of the form vi 1j, right, where I is not equal to j, right? So this language is also not regular, and to prove that it's not regular, you can essentially use the same, you can use closure properties essentially, right? Essentially saying that the language above, this language, you can write it as the complement of L intersection with 0 star, 1 star. Let's see why this is true. Well, L complement is just all the strings that are not of the form 0, 1 star, 1 star, which clearly contain the language on the left. And I intersect it with 0 star, 1 star to port it to be just a sequence of zeros, sequence of 1. So I get the language on the left, right? So, so this is a strong indication that the language on the left is not regular, right? Because to begin with, if it was regular, I could apply the same transformation to show that, to show L can be written in a similar fashion as a complement of this language, intersection with some regular expression, right? So the fact that, so it's enough to know a few number of languages that are not regular, and then because of closure property, you can prove that a lot more languages are not regular. Okay, and we will get back to it later on. Okay, so I still want to sketch to you a proof of why this language is not regular. The proof I'm going to give is a very sketchy proof. It's very hand-wavy. You don't need to know it. I'm just providing it because I think it's a good intuition to kind of understand what's going on. And because the real proof we will see later on will use completely different machinery. So I think it's useful to kind of get intuition with what we currently have to see why this language is not regular. So the idea is that let's assume that it's regular. So it has a regular expression. There is some regular expression that recognizes this language. Namely, we have a string. We have a really long string that is some regular expression, who knows what's there, blah, 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 blah. But this regular expression, think about it as having m characters. It has to have some finite length, right? Otherwise, it's not a regular expression. So there is the regular expression has length m. And now think about a word in this language which is really, really long, much, much, much longer than this m. So think about, for example, the word 0, 2 to the m, 1, 2 to the m, okay? And so this regular expression have to match this string, which is much longer, right? Now, if you think about it, the only way a short regular expression can match a very, very long string is if we have a cleany star somewhere, right? So, and in fact, there might be more than one clean star. There might be many clean stars. So now we just have to kind of go through the cases. So if the regular expression has a clean, think about matching this long string that I said with the regular expression. So there might be some portion that is in a clean star, and it matches a run of zeros. Okay, and there might be some other part which also has clean star on it, whatever the expression is on it, that matches a run of ones. Okay, if this is the situation, then we are done, right? Why are we done? Because whatever the run of 0 is, we can apply the clean star again to generate a string, which is, if let's assume that this was 3 zeros, we can use the clean star again to generate 3 additional zeros, right? And we will get still a string that the regular expression would match, but the number of zeros and 1 would not be balanced, right? And similarly, if we have the clean star matches a run of ones, we can apply the clean star again to get a larger number of ones, and this would break down. So this is not possible, right? Again, let me emphasize, this proof that I'm sketching, it's very sketchy. I think that's the right way of saying it. So the other possibility, and you can think about it just as an intuitive explanation of why it shouldn't be possible, but I'm not going to formalize it because, as I said, we're going to see more formal ways of proving it later on, once we speak about automatas. Okay, now the other possibility is that we have a clean star that matches both zeros and ones, right? So it must match a string of some zeros, then some ones, right? But this is even worse, right? Because then what we can do, this part matches a run of zeros, right? This part of the regular expression matches a run of ones. This here in the middle match this 0, 0, 0, 1, 1, let's say, right? This is the middle part. But this middle part, right? This middle part can just be, we can again generate it twice, right? So we can get 2 copies. It would still match this regular expression, but then it definitely would not be in the regular languages because we are going to have run of zeros, run of 1, run of zeros, run of 1, which is of course not in the language. So this implies that the language is not regular. Again, this was a very hand-wavy proof. So you should, believe it only after consuming a large amount of salt, and 1 grain of salt would not be enough. Okay. So next. Well, I guess there is no next, so this is it. Thank you.